Okay, thank you. Thank you for your response. Okay, so I'm just continue the last topic we were discussing in the last session yesterday, and we just want to resume our session. So in the last class, what I try to recall, we were discussing about the data set split. Sometimes it is called test and train or train or test split. So, okay, thank you. Thank you for your response. So what we were discussing about why we need to divide your data into training and testing. So first, let me revisit that concept that because the basic objective of the AI and machine learning is to train your machine, train your model, not a human being. So human being, okay, someone want to reshare the attendance link. Just I have shared, okay, let me do again, 1 minute. Yeah, just I have shared the attendance link again here in the chat box. You can refer. So the objective was that to train or learn or make able our machine, our model, so that they can take some decision, they can predict something. So as a human, throughout the life experiences, he or she can learn many things, and that process is same. How the human learn by seeing the examples, by seeing the things. So meanwhile, I request to everybody, please please mute yourself, please. So human also learn through the examples. If you feed a image at the front of the human being or front of the me that I have never seen the particular animal, you can take the photo of animal image from the somewhere else, but I never seen that animal, so I will not able to describe it. I will not able to predict it what is that. Similarly, it happened with the machine. So what the process were invented to make this machine so that the machine can learn. So machine need the experience. Experience means here data. So first thing, very basic structure I'm talking about. Then I will also discuss about the validation data set. Someone have asked in the last class. So normal practice is that whatever data is given to you, normally 70 to 80% data was divided or split into the one category that is called trained data set. And another remaining, you can see to 20 to 30% data we use for the testing purpose. So purpose is that first I will train the data, train the model will learn from that data. Once model have learned, we just want to assess the performance. I want to assess the performance means whether the model have learned and it is under my expectation or not. So I will feed the data that is unseen data. This data also called unseen data, because whatever the model you have trained, suppose that is a model you have trained with the training data, you have a lot of maybe text data, maybe numerical data, maybe image data. The model have gone through it. Model know what are the dog, what are the cat, like that. But in the real life, the same things, very less chance the same observation, same data will appear at the front of the model. Model have to work in very real environment. So in the real environment, we have to feed some data that model never seen. That is called unseen data. So the test data we feed to the model, a model predicts something. Model will predict something. So whatever the model have predicted, whatever the real value we have already with the data set, we try to compare it to assess the performance of model. Somebody have asked the attendance link. I have shared. It is this link is not working. Just I have shared the attendance link. It is not working.
It's not working.
No, sir.
Working.
I think it is working.
I think it's working.
Okay, so somebody having a
Somebody
problem.
having a problem.
Please first
Please
log in
first log in
by your
by
Gmail ID,
your
then try
Gmail
to
ID,
fill it.
then try to fill it.
Okay, mute yourself,
Okay,
please.
mute yourself, please.
Please, everybody mute yourself. Okay, thank you. So somebody have may have some problem because you need to log in some in the Google ID or somewhere. So once you log in it, then you can fill. So that the problem you may have. Please try to relook it. So here the predicted value and the real value we have. I will also discuss a very important terminology. Yesterday also somebody have asked the validation, you can say validation data set. There is basically you can say the three terminology. Again, mute yourself, please. Okay, so there are basically three terminology: train, dataset, test, dataset, and validation dataset. So first, let me cover this thing in the detail with the hands on. Then I will cover the validation. Okay, so okay, I will going to disable the attendance link after 10 minutes. So please, everybody, just log in and give the attendance. Okay, so let's have a discussion. How to do it? So what happens? Suppose the data set is given to you. Data set is given to you, and the data set indexing. You can assume the indexing like row number 1, row number 2, row number 3, row number 4, row number 5, 7, like maybe n number of rows are there. Against row maybe column 1, column 2, column 3, column 4, dot m number of column. So you can assume the data set like that. I have also one data set just for uh, your reference. I can open the insurance data, so you can see the data set you have. How to make attendance? Just fill the form. And Ranjan Kumar is asking how to make the attendance. So yesterday I think you missed the attendance. That's why you are asking the same question. The link is given to you. Just open the Google form and fill, and just submit it. It will come to me. So the Ranjan Kumar, it's okay with you? The link is I have shared with you. You just fill that link and just submit it. Okay. So that data set is given to you. What are the basic problem I'm just discussing with you? It comes in the real life. How to split the data? So suppose the data is given to you. Somebody will say, just you suppose there are 100 rows. Very simply, simple case I'm talking. So take the 70 rows, first 70 rows for the test data, and the remaining 30 rows for sorry, that is a train the data for train data set and test data set. So it is totally wrong practice, totally wrong practice, because in the real life the data set, whatever the data sets you will receive, it arranged in some order. Maybe by roll number wise it is sorted, maybe first name or second name wise sorted, or maybe date wise sorted. So sometime in the real life the data was sorted in or ordered, it better to say. Maybe the data was captured in that time, it was arranged, maybe roll number wise arranged, maybe in another way the data is arranged. So once the data is arranged or ordered, or if you apply to split the data, like first 70% data like a trained data and remaining 30% data like a test data, it is totally wrong practice. Because once the data is arranged somewhere else or in another format, means it 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 lose its randomness. In the machine learning or AI, you require the uncertainty, you require the randomness. So how it can happen? Just to take, let me example. Suppose you have 100 data, and there was a gender was a column, and male and female there is a two option. Luckily or unluckily, you can say data was ordered with reference to the gender wise. So you can say the female will be arranged at the first positions, or maybe you can say there was 70 females. For one case you can consider, the remaining 30 are male, you can consider. You want, and the image is given here also, you want to train a data, that may recognize of the given image, data is male and data is female. This just simple problem you are working on. You want to recognize or predict the given image is male or female, and there were 100 images, and the images were ordered with respect to the gender wise. Means first initially there are female images, then male images. Unluckily you have split the data 70%. The first 70% data are training data. You can imagine that there were 70 images, all are for the female images because that was sorted. In the training phase, all the training you are making for the female data, you don't have any male data. Because male data are there are 30% data that belong to the male images, and you have made that data into the test data. So during the training, your algorithm will learn about the female, how the female look like. It never learned about the male property. Male is a category. So the algorithm or model never seen the data that is required in the real life to predict, because your algorithm must learn how the male look like, how the female look like. But you can say here a very special kid, 100% data belongs to the one class that is called female. Or in other cases may happen, most of the data, if data is sorted, most of the data will belong to the one class. So during the training process, you require to give the enough data to all the classes. Suppose you are working with the binary classification, means whether male or female. So training data required balanced images, almost equal number of images of both the classes. So that model will learn the property or trend or characteristics that it can make use during the real time prediction. So that's why this kind of data splitting is not recommended at all. So what you have to do? Simple process. Whatever the data is given to you doesn't matter. Suppose data is given to you about 1 to 100, and data is arranged some order. Data have some order. I don't worry about that. You can say the roll number wise data is arranged. I don't worry about that. So how to split your data? Suppose 70 rows you want to select, because 70% data you want to make as a split as a training data. So you have to select all 70% row randomly. So that function you have to use in the real life when you're going to split the data. So out of the 100, the observation, it will select the 70 rows randomly. So it may select the first, then last, then somewhere else in the middle, then somewhere else in the middle. So it there is a higher chance whatever the 70% data will be there, it will be balanced in term of classes. It may have out of 70 there may be 30 male classes, or 40 or 30 maybe female classes. So it is kind of balanced data. So somehow when you pick the random images or random data from the given data set, it's better process, because it will give the real picture. It include all the randomness, all the certain uncertainty into your data set, because that randomness, that uncertainty will be there in the real life applications. So you have to randomly select the data. Okay, so how to do it, that I'm going to tell you in hands-on session. So okay, let it go. So somebody have asked some question, trend and test data should have equal portion on the each class. Yeah, you can say ideally it should be. Ideally it should be. So what he when somebody want to convey, I just let me explain whatever I have understood. Maybe I'm wrong, but let me. Okay. Ideal case I'm talking about. Suppose there is a trend data set, there is a test data set, or there were two classes. There are two classes, 0, 1, male, female, whatever want. In the trend data set, there should be equal number of observation for the male, there should be equal number of observation for the female. That is ideal case I'm talking about. Ideal case I'm talking about. So whatever the training data set you have made, there maybe have suppose three classes, class A, class B, class C. So So we have to split the whatever the data set you have. If you try to count the number of observation of the class A, number of observation of the class B, number of observation of class C, so it almost equal. It should be almost equal ideally, but in the real life it never happen. Or what is the benefit of randomness in the training? I have explained, Vivek Sarmaji. I have totally explained. You can relook your video again if you missed it. With the detailed example, I have made it clear why we need to divide or split the data with randomly. Because I started with the problem. If you don't apply the random selection, what the problem may happen? So please revisit the video if you have missed it, Vivek Sarmaji. Okay, let me continue here. Okay, so now let me go with the example and with the hands-on how to do it. So suppose let me open the R Studio. Here the R Studio I have opened. You know everything about the R Studio. Yesterday we have discussed. My path is there. Just let me again set the path. So this is the path is there. I just want to make it as a working directory. So let me do it. It will take 1 second only. So set WD, it may be you can revise all the concept we have covered in the yesterday. So the path I have pasted over there because my dataset is there. Once it become a root directory or working directory, I don't need to write the complete path every time. So it is just make my coding very easy, other than no benefit. Okay, so that thing happen now. Look over here. So don't be focused on, there are many methods to split your data in the training data and test data. 2 or 3 methods I will explain over here. And when you go for further study, you will able to connect yourself. It will be easy to understand. So first method, what is that? Sample size. Okay, what is the sample size? Okay, suppose a data set is given to you in CSV file. Okay, and you have to split your data into 70% and 30%. So method one is a very simple method that is called hard coding method. First, what should you know? You should know how many observations are there. How many observations are there? First, you should know how many observations are there. Out of those, some will go to the 70% category and someone will go to the 30% category. So what is going to do? I'm going to do over here. Just try to. Okay, so let me close it. Okay, sample size is a variable. Don't worry about that. So it is variable is going to store that things thus I have discussed. How many observations are there? How many observations are there in the data set? So how to do it? And okay. So it is talking about. Let's first discuss with the insurance data we have. So first, this variable I want because number of rows. So again, let me explain over here what I'm going to do. I'm going to do whatever the observations we have. I'm going to know how many observations will go to the training test. That is called training test. Or sorry, training data set. How many observations you need it? How many observations you need? Whatever the total observations you have, what is the total observations you have, multiply by 70.7. What happened? Actually, why I'm doing over here? Because later I have to apply the random function. I have to apply the random function. For what? Whatever the observations you have, 1 to m. I have to select random observations here. That is 70% of the total number of n, and I will mark them as a trained data. So how many observation I need to select randomly? That okay, I have to select the randomly 7. That is a percentage. I want number. How many observation I need to select? That will be marked as a training data. So that line of coding I am explaining over here. So it is written over here. The floor means it just make the things either one integer next to the number or otherwise back to the number. So floor or ceiling is the concept that we know everybody. So we are not discussing over there. What about total number of observations? The total number of observations, first we need to the data set. First we need to upload our data set. Okay. So let me upload my data set over here. Uh, so I have to create a variable insurance. Then everybody know read.csv we have to use. Then you have to pass the file name that you want to upload, and you just check it works or not. You see the data set is uploaded. Now whatever the data set is given to you, you don't know the number of observations. So there is a command nrow. Nrow is a command, and you can pass your data set. It will give you the idea. Total number of observations you have 1338. So total number of observation have you 1338. So out of 1338, 70% observation you have to select. So it may comes in the fraction. Maybe say you can say 235.5. So for that we have used this function. You can either use the floor or either you can see it will make the floating number into the integer number. That for that purpose it has used. Okay. So n rows is the total number of observations in the data set. Out of 70%, what are the number of 70%? 5. It is 75% data I want to just make a training data. So it may be 70 or 75%, doesn't matter. So how many observation we have to select randomly? The answer is that 1003. So just let me run that command. I hope the command is clear to everybody. You may write the doubt in the chat box if you have any clarification if looking for. So you see, floor is something that make the floating point number as an integer number. Total number of observation over here 1338 something, and what is the 75%? The 75% number is sample size. In the sampling, it is called sample size. We have seen what is that number. Sorry, it is here. You see. So what the things I can interpret? 1003 observation randomly we have to select from the given data set. Okay. Next. Forget about the seed. We need to set the seed value. To forget about it. We will discuss sometime later. So now I want the index number. So I am not going to split the data set right now. I want to know the index number. Try to understand what I'm talking about. So it's a little bit tricky to understand. That's why I'm just going in very detail. The data set giving to you. Okay. So you assume that it is indexed by 1 to n, like sequence 1, 2, 3, 4, 5, 6, 7, like it is indexed like that. So randomly you can select first index, the third index, fifth index, or like that you can select. So ultimately you will say my training data may have index number 1, index number 3, index number 5, or dot 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 something. So what I need to select? I to select the index number randomly. Means whatever the data 1338 was given means 12 dot 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 1338. Randomly I have to select index number that should be 003. Total number of index number I have to select. So I'm not going to select the complete row right now. What I'm going to select? The random index number I'm going to select. So the code is written over here. You see the train index. The train index is a variable you can say. First, let me copy it, then I will explain what is going to happen with the code. So you see, I think it is visible to everybody. Sample means a random selection is called sampling. So everybody know the sampling. Sampling means the randomly we have to select something. Ultimate you have to apply this. Ultimate what you are doing? You are doing sampling. Like the sample at random you have to select something. So suppose so there is a function already in the R. Sample is a function. You can directly recall it. You can just recall it. What you have to do, how many observation you want to make random selection. So that is size of sample is a sample size. The sample size is already there. That is 1003. So sample size is a variable that contain a numeric number 1003. That are the observations I want to create. Technically, it is called the sample size. You want to make a sample of how many observations. So the parameter is given, size is the parameter, and the value you have to pass. It is a sample size. Okay. From where it will select? From where it will select? It will select from here. Yeah. So sequence length is a function. So whatever the observation, a total number of observation are there, it will arrange them in the sequence like 1, 2, 3, 4, 5, 6. The sequence will be go up to the 1338. From that sequence, because that is an index, you can consider it is an index 1 to n. Sequence length is a function that is create an index. You can say how long it will create the index, n number of rows. N number of rows means 1338. So out of that index value, the sample will randomly select 1003 observation randomly. Or it is going to store in the new variable, or you can say it is a become vector now here. So now you can see which number or which index number. I'm just forcefully saying it is an index number. I'm going to, I have selected send randomly. You can see over here. The total there are around 1003 observation I have selected randomly. Observation, sorry, index number. First randomly selected index was 654. Second index was 1299. Third, like that, you can see it is totally random observations or random row number we have selected. So what I have done till this time, I have selected this, I have selected this, I have selected this. Now I need complete row. I need now complete row. I need now complete row because that was the only index value. For the training purpose, I need a complete row with along with all the column. So next I am going to do the same thing. So the trend index already I have with one. So okay, so again let me explain over here one new thing. So whatever the things required with the time, I will continue discuss with you. Yeah. So the dataset Excel dataset was given to you. That is a two-dimensional matrix you can consider. This is two-dimensional matrix you can consider. So this is really it is a matrix. So matrix is a vector. Multi-dimensional vector is a matrix. So it is a vector or matrix you can say where one dimension is the row, another dimension is the column. Another dimension is the column. Okay. So how to access the particular row or particular column in the array? The same concept I'm going to use. Suppose your variable name is insurance. Insurance is the variable name where the complete data is stored. So I can, because the two-dimensional data structure, I can use two indexes. So here I have to write something. Here I have to write something. So it will represent the rows. It will okay, and it will represent the column. It will represent the column. Means suppose in the data set I want to access the first cell. Suppose that data set is given. This is the data set. Suppose I want to access this particular cell. I have to pass. I have to pass. Suppose data set name is X. So I have to pass X. Which number of row you want? First and first column. So it is typical. The matrix cell will represent the, this cell is going to retrieve. First complete row I want to retrieve means what? X. All complete row, and if you try keep it blank means all column. Blank means if you try to make it empty, if you are not mentioning means all. So this syntax is going to access or print first row with all the column. So now that concept I'm going to use it over here. You see, now I'm going to create a real data set that is the trained data set. So insurance is the variable. Insurance is the variable that contain this complete data set. Complete data set. Randomly, I will select something. So where are the random indexes are there? Random indexes are there. These random indexes are there. It contain the row index. So means index number like the simple you can see here. So another way, multiple row, how can you select over here? You have to pass a vector. Then vector row number 1, row number 5, and row number 8 I want to print with all the column. So that command will work. So here you have to pass a vector that contain a number of or indexes or the sequence of row that you want to retrieve. So that value came from where? From this. The train indexes you have already there. So just I have passed that vector and with all the column. What it will do? It is going to select already the indexes are there randomly selected. It is going to retrieve only those rows with all the column. That is our objective. That is our objective only. So let me do with you, and I hope you will understand all this concept. So just what I have explained, I just done. Now you can check it. The complete data with all the columns. But there is a train data because there are only randomly 70% rows, means 1003 rows were selected. So this data set I am going to use for the training purpose. Testing data, what you have to do, whatever the indexes was selected for the training data, you just discard all those rows. Means the remaining rows sequences become test data. So if you use the negation operator, minus operator, means whatever the indexes were mentioned in this variable, we are going to discard it. Means remaining are going to be a part of the test data. So very simple, very logical way we have written. So just let me run again that command. You see, can you just check it? Complete data set, but having a limited number of rows. You can see a limited number of rows, whatever the 300 400 rows are there. So that become a test data. And when you create a train and test data, then in the intersection overlapping between training and testing data should be 0. There should not be like that one observation is part of some set of option part of both the training and testing data. It is not possible. Why? Because that's why it is called unseen data. Because whatever the data set you have used in the training, I want to check my performance with the test data, and the images should be unseen. The model has never seen. So there should not be any overlapping. There is a question of many exams comes with. So that things you should remember. Okay. So that was the first method you can use for the training and testing purpose. So some slightly modify, we can use it. A lot of predefined library function also comes. I'm not going to discuss with that one because very easy to understand. You can use it if you know all the coding from the scratch. Another is very simple. You can use the n is simple new variable you have created that store the total number of observation of your data. Now another form of sample function you can call over here. You can see now I'm just going to just randomly select the 70% indexes for the training data. So I'm going to select the index. So another way of applying the sampling function is over here. You have a total number of here. Earlier I have done with the sequence length function we have used. So if you don't want to use it, just give the range 1 to n. N is already there. So automatically it is going to create a sequence. So you want to recheck it, you can recheck how it works. So if you write this kind of coding in the R, okay, suppose n is 120, okay, then you can if write it will going to create a sequence. So ultimate what the things we have done, this number of sequence we have created, and out of that what we have done, 70% of n, I want to select randomly. Most important thing, replacement is false. In the sampling, okay, let me discuss. I think it was a little bit different topic for learning purpose you required. So what I want to discuss over here, suppose A, B, C, D, E are the observations. I want to randomly select three observations. So three is the size of training data you can consider. So it may happen, every time you may select the A and A, it become a training data. Everybody agree? Because I'm going to select the things randomly. So it may happen, first time you choose the A, second time you may choose the again A, third time may you choose the again A. It may happen A and B. So it is called sampling with replacement. It is called sampling with replacement. Replacement means you have selected the A in the first drawn, in the first scan, your first selection. In the first time you go for the selection, you have selected the A. That's okay. In the second run, A again is a part of a selection because you are not going to discard the A. So A may become again a part of the same selection. So this is called simply with replacement selection without that is called without replacement. Sorry, it is with replacement. Why? Because I'm going to replace A with the A. So A item set that already you have selected, it may become a candidate for the next selection. Okay. If you have done without replacement means it is not going to become a candidate for the next selection. So once A is selected, in the next selection you have made with the remaining data set. Okay, so both kind of sampling algorithm used in machine learning. In the coming days I will discuss about when you should use the sampling with replacement or without replacement. Yeah, so that's why I have written replacement is equal to false, because I don't want to repeat the same item again. So the item is going to replace itself false. I don't want to replace the item with itself. So once the item is selected, it is not going to be part of the next selection. So whatever the item you are going to get after the training test data set, it is going to be unique in term of index value. Going to be unique in term of index value. I hope I made it clear. So that I have written the replacement is false. I don't want to replace. I don't want duplicate item. So you can run that command also, and you will see again you got the index, then the same process. You can use the training and testing split. Method 3 are there in the one line you can do. So whatever you have done, the sample function you have called, you have total number of observations are here, and out of those 70% observations you want to consider, and going to store all those index in the DT, and again DT for the training data set and negation of DT for the testing data set. Other than that, many various variety of coding functions are available. A lot of packages are available, so you don't need to write all those things. Just pass the data set and percentage of training data you want to create. Just pass it to parameter. So that things you can also use. Okay. I'm just moving ahead. Any doubt, any discussion just you want to make, then you can just discuss with me. In the chat box you can write. Otherwise I'm going to start a new topic. It is a part of training and testing data set that is called validation. A method is simple. It is very shortly it has written. This is a total number of observations. That is 1338. Out of those, this 70% observations I'm going to select randomly by using the sample function. So whatever these two functions are written in very short form is that method 3. Very short form is that. Answer is why we are going to sort it. Okay, because here this it will n number of row is it will going to give the number only like 1338. So once you have 1338, you want to make a sequence, maybe by using this code or maybe by using a sequence len function. So you want to make a list of that number like 1 to 1338. So here making the list, we need to sort it. We need to sort it. That is only. Other than no. Okay. So I will share the resource. Don't worry about that. So can we start with the validation? That is a very important part of testing and performance assessment. Okay. Okay. Again, try to understand. It's very tricky to understand. Okay. So whatever the data set is given to you, what happened over there in the real life, we require a trained data set, we require a validation set, we require a test set. It is a very common terminology. So the training set and test set anybody can understand. What when we come the validation set, a lot of confusion, a lot of questions comes in our mind. So just I will explain in the brief, try to understand. There are two thought processing to understand that problem. Many scientists, what they consider, they don't have any confusion with the test data set. So whatever the data set is given, the one way or you can say in many literature they consider that the data set you can divide the test data set, no confusion. In the trend data set, actually there are two kind of training data set. That is called real trend data set or validation set, trend set or validation set. One way of literature you will find it, test data set is the one part. Under the training, you can imagine in the trend data set, again you have to divide the data set into the two part. This is called trend set and validation set. Sometime what happen, some literature refer that there is a training data set, no confusion, there is a training set, and when you go for the test set, there are two options, validation set and test set. So what I want to convey over here, sometime the validation training test and training set and testing set is okay, but where the validation set are there. So sometimes people will visualize the validation set is a part of training data. Sometimes people say no, validation set is a part of test data. Okay, so that is only perspective. In the real life, both are same. So it is only perspective. It is only perspective. So in the real life, both are talking about the same thing. Both are talking about the same thing. Okay, I will explain with this perspective. This is more dominating. It is more dominating. People talk about, most of the literature talk about the training set. We have to divide again into the two part, the training set and validation set. So with this perspective, I will continue my discussion. Now what we are going to do, very tricky to try to understand. What we will do now, whatever the data set is given to you, suppose 30%, just is a number, 30% is the test data, don't worry about, don't touch it. Now 70% data you have, some big portion, you can say out of 70%, again 70% data we will use for the training purpose, and 30% data I'm going to use for the validation purpose. So just try to understand the structure. Why we are doing, I will discuss in later. So try to do what we are going to discuss. Whatever the data set is given, 30% data you have to consider the test data, no doubt. In the training data, that is, we have 70% of total data. And out of those 70% data, I will going to consider as a trained data, and 30% I'm going to consider as a validation data. Okay, in many literature it is written over there, suppose 100% data is there, then people talk about the 50, 25 and 25. This kind of literature you may find. So this is called test data, this is called validation data, this is called training data. So this kind of ultimately the same thing we're talking about. Some portion of the data you have to make training data, test data. Some portion you have to consider for the validation test. Some portion you have to consider for the training set. So these are the terminologies. Someone are writing something. Let me just read it out. We can also maximize the training data percentage if you are planning for a validation. Yes, we can do it. Yes, that's why I have written in many cases 70% 70% data for the training data, where 25 for the validation and 50 for the training, remaining 50 for the testing. So it is a number only. These are the numbers. Just in the machine learning model like SVM, validation set is used to obtain the optimized value. I'm coming. So that is the structure wise I have explained. Now the question is why we are using. The question is why we need the validation. Actually, what happened? It's very tricky to understand. If you go to the literature, you will find the purpose of the validation set is that a parameter optimization. Parameter optimization. Somebody had already written that thing. So he has written in the SVM something you have to optimize the parameter. Parameter optimization. Sometimes we will use the parameter selection. Sometimes we talk about the model tuning or parameter tuning, you can say. So these are the things we implement and we achieve through a validation set. So some have written correctly. So then we have to understand what is the parameter optimization, parameter selection, or model tuning. What is the meaning of that? So let me take the example, very simple example. I will discuss with that example. Suppose you want to preparing for an interview. You are a person. You are preparing for an interview or for a competition purpose. So what you will do? You will try to do practice with the mirror. You will try to do the practice with the mirror. You have a mirror. You will every day you come and just sing a song or dancing, whatever, for whatever purpose you are preparing. So you do the practice. You do the practice with the mirror, suppose, or that. So you can consider it is a training. It is a training. So require a lot of repetition. It requires lot of time you have to do the practice. So that's why so many observations and maximum part of the data set we consider as a training. The same concept, exactly the same concept is there. Because here what you are doing, you are learning. Here what I do, you are learning with the front of mirror. So you do something, you practice it, you sing it, and you see day by day, you just improve. Now next year, what you will call? You will call your family member. You sit in front of you, your family member, and you will repeat your performance over here. So this is called validation. This is called validation set. So the training data set was there. You have learned something. Now you went to with other member of the family, that is called validation set, and you just given your performance. They will give the feedback. That is called fine tuning. Or parameter setting means yeah, you should stand like that. Your language was not good. Please don't move your hand so much. Your eye contact was not good. Like that, they give the feedback. So ultimate validation test of as validation tests are used for parameter setting, fine tuning, or it improve the performance. So what it has done, you would go for the real testing. Real testing means real performance you have to make, where they are the person, they have never seen your performance. So that is called testing data. So testing data means real environment or real day where you are going to perform. So it will only check your performance. It will only check your performance. It will not going to give the feedback. It will not going to give you another chance to repeat it. So it will give you performance means your marks was 70% or you are fail or you are topper. So it is a kind of exam. So testing data is a kind of exam you can consider. Validation set, again, it is a kind of testing. That's why there is a big confusion. Now you can understand. Now you can also think in the validation what we are going to do. In the validation, we are going to perform with someone and they are going to say you are not good or you are good, like that. And that's why it is a part of testing somebody will consider. Then somebody will say, no, no, don't think in that way. It is a part of training, because what they are helping us to improve our learning, improve the machine learning. So it may become a part of training. So the space or the contribution of the validation set is that some set of people may consider the part of testing because ultimately you are testing, you're going to test yourself with a member of your family. Somebody will say it is a part of training. So now hope you can understand that why there is a two thought of processing about the perspective or the validation set. Now I'm going to discuss about the technical thing. In technically what happened. So suppose you have a CNN model or any other model you can consider. There are so many parameters. Whatever the algorithms you have, so many parameters are there. So simple linear regression model. Suppose there is a learning rate. So there is a parameter or learning rate you want to set 0.1 or 0.2 or 0.3. A lot of options are there. Similarly, CNN, a lot of layers are there. You can say I want to work with the 2 layers. Somebody will say no, 3 layers. Somebody will say for the 4 layer. And so many activation functions are there also. So which parameter is going to be selected by you? It randomly it happen. How many layers you will set for the model? Which activation function you are going to set with one? So this is called the parameter setting. So what happen? Then you have to create so many versions of, in the real life that happens, so many versions of the same algorithm, maybe a CNN or maybe a SVM. Somebody will talking about the SVM. So many versions you have to create with, again, different setting of the parameter, with this different setting of the parameter. Okay, different setting of the parameter. Now all the version will go for the training data. They will train, and they means you have a lot of model of the same SVM. You have a lot of model, because every model, when you are going to change something in the parameter, means you are going to create a separate model. So you have a version 1, version 2, version 3, version 4. So now you have a 4 model. Which is better model? Now how do you decide which is better model? Because in the testing, it is a final exam. So here we required a midterm exam. So there is a validation set. In the validation set, you have to test your data. You have to test your model. And during the validation, which model which perform better, which set of parameter you will consider as a final model for the testing purpose. Okay. Any question? Any question? You got it or not? Now you got it. The objective of a validation set, why it is used. I hope I made it clear. Okay. Okay. Going ahead. Now, what are the methods for a validation testing? So in the validation, the first method we have discussed about the holdout method. The hold down method means that already we have discussed we required a big data set, and around 60-70% data will become a training data, and the remaining 30% data become a test data. It is called hold out method because one part of the data set just you have hold out, that is your unseen data. Another so famous terminology and the method of validation we use, that is called k-fold cross validation. I hope everybody have listened that word. Everybody have listened that word. K-fold cross validation I'm talking about. So what happened over here? A very simple method. Whatever the data set is given to you, it is a different way to look the same problem. Whatever the data set is given to you. So you have to divide your data. You have to divide your data k part of equal size. You try to understand of equal size. Suppose 20% data is here, 20% data is here, and 20% data is here, and 20% data is here, and 20% data here. So 1, 2, 3, 4, 5 part of data we have divided. So we have a 5 part. So what happened, that 5 means k is equal to 5. So it is called fold. So k is equal to fold. How many group you have created from your data set, that is called fold. So k is equal to 10 or k is equal to 5, k is equal to 20, whatever the possible it can be there. Now you have k number is equal to 5, then you have to repeat that process for 5 number of time. How? In the first scan, you make that part as a training part, sorry, as a testing part, and combine all the remaining part as a training part. If the first scan is over, you can just keep the performance of your algorithm over here. In the second scan, another part will be a training part, a testing part, and remaining were the training part. Similarly, you have to repeat our process for what number of k you have selected, for 5 suppose. Okay, so in that way you can understand. It is called k-fold cross validation. So at each step, one part of the data will be used as a testing purpose, and combinedly remaining part of the data set will be used as a training purpose. So what is the average performance will come over here? I will consider as a final performance during training. Later you have to test it again with the test data. So whatever the training data you have to apply this process under the training data. Again, you have to make some combined part of the test training data, and whatever the block the part you block it become a test data. So it is part of training. The k-fold cross validation is a part of training. I hope I'm clear. Any confusion you can write on the chat box. Okay, so another method is a leave one out cross validation. It is a special kind of validation, cross validation, what we have over here. Suppose here what we have done, whatever the data set is given over here, we select only one observation at a time as a test data, and remaining observation as a training data. So ultimate what we are doing, suppose there is a total 100 observations. So ultimate I am going to apply the k-fold cross validation where k is equal to 100. That things I am doing. So here instead of in the typical k-fold validation, some set of data we have to block for the testing purpose, remaining for the training purpose, and you have to repeat that process for multiple time. And leave one out method means only one observation you should consider as a test data, and remaining data set you will consider as a for a testing data. Got it? Leave one out method. Okay. In the okay. Shraddha have written, I think no means here. You can consider the leave one out cross validation is a type of cross validation where k is equal to one. Only that you can understand only. So only single observation you have to select for the testing purpose, remaining all the observation for the training purpose. Then bootstrapping. It is used for the random forest or ensemble learning if you know. So in bootstrapping is also kind of making a training and test data set. So most of the part I have covered. Whatever the observation is given to you over here, randomly you have to select some data set. And when you talk about the bootstrapping, normally it comes with the replacement true. So whatever the things over I have covered, you have to create randomly where replacement is equal to false. But in the bootstrapping, always replacement should be true. So that is the difference over here, the bootstrapping and another method. So just you can just explore by yourself, not 1%. Dr. Shraddha, not 1%, single observation, not 1%. If you have a 1000 observation, first observation will become a training for a testing purpose. 999 become for a training purpose. So not only 1%, only one single observation become a part of testing data. Okay, Dr. Shraddha, now it's okay. Okay. So that part of training data set is splitting, training, testing, validation is over now. I'm just going to start the new topic over here. That's also come under the fundamental. Type of attribute. We have also discussed in the last day the type of attribute. So basically, there are various kind of attributes are there. Attribute means I'm talking about the Excel file, data set. Okay, I'm not talking about the data type or variable of the R and Python or MATLAB. I'm talking about the data set characteristics. The type of attribute means this column I'm talking about, like gender, BMI, children, smoker. There may be a variety of attribute, variety of features. So if you're going to categorize all those attributes, you can understand some categories called nominal, some are ordinal, and some category are real, valued, and numerical and continuous data. So these three categories I'm going to discuss in very brief. I will cover because a lot of time we have just discussed. So the first the category is the first type of variable may be categorical data or the nominal data. Both are the same word. The categorical data or the nominal data. Categorical data means where the class and labels are the category. So means you are going to divide your data, and data are here you can see with the example you see over here. So like a gender is a category. Whether you are male and female, it's a category. It is not a number. Smoker, yes or no, whether you are smoking or not smoking, this variable is a categorical or nominal variable. Reason, whether you are for the you belongs to the south part of the India or north part of the India, it is also a category. But if I say age is not a category. But if I say age is like a young, middle, and old, then it become a category. But if the age was given like that 19, 20, a number, it is not a category. BMI is not a category. If you divide discretize the BMI like a average fatty or under or something, you can give these kind of things, it become a categorical variable. Expenses is not a categorical variable, it is a numerical variable. So now you can understand what is the meaning of categorical variable. So categorical variable is something that you can see the value are there and sub labels are there, like gender is a categorical variable having a two label, male and female. Region is a categorical variable having a four region, north, east, west, south, like that. So these are the category plus it label. So there is a two word category, it is called label sometime, or again label. These are two words. So under category like a gender, Gender have a, what are the different value it may contain? Gender contain male and female. So there's a two level under the gender. How many distinct values are there? Or suppose I talk about the region. So region may be North Indian, South Indian, East Indian, or West side belongs. So there is a four level. So that is called level of a particular category. How many distinct value that category may contain? Okay. Now, most important, I'm going to discuss. The categorical variable, sometimes called the nominal variable, is one that two or more categories, but there is no intrinsic ordering to the categories. There is no intrinsic ordering to the label. Means you cannot arrange a female gender like in increasing or decreasing order. You cannot arrange if the variable this is the good variable, good labeling, or is it bad labeling. You cannot do it. So if there is no agreed way to order them like a highest to the lowest. Okay, like a blood type, blood group. It is a categorical variable, but you cannot say A plus or B or O negative is some different kind of group. You cannot order it. You cannot create a meaningful ordering with them. The zip code. What is the ordering with the zip code? Gender types. You cannot have the ordering with them. Eye color, all those things you don't have order within the label. So if this is a property, it is a categorical variable, but if you are not able to make the meaningful order with the label, it becomes the categorical variable. And another is the ordinal variable, very similar to the categorical variable, but the difference is that it have the order also with respect to the label. How? Suppose you can say the people, you can classify the income, maybe say the low and medium and high. So the economic status is a categorical variable, suppose. Under the economic status, the value may be low, maybe medium, maybe high. So this is also a level of, there is three level of the economic status, but under the three level, there are the ordering, meaningful ordering. You can understand what is the meaning of low income, what is the meaning of medium, what is the meaning of high. Okay. Another examples you can say, you can consider like that your education level, high school, like graduate, master degree, and PhD holder. So this kind of level of education, you can have order. You can create a meaningful interpretation with the label, like a income level, like a satisfaction, like a feedback is a ordinal variable with extremely dislike, neutral, like, extremely like. So these are the label of the particular category, and that label may have some ordering, then it becomes the ordinal variable. So many participants are confused with the two term, categorical variable and the ordinal variable. The difference is only one, that if the label within the category, you can create a ordering, meaningful ordering, you will say it is our ordinal variable. If among label you cannot arrange with respect to the meaningful value, meaningful interpretation, it will become a category. Okay, so going to the next, here you can understand what is your gender, male and female. It is a categorical variable or ordinal variable. It is a categorical variable. You cannot make an order of them. It is males are better or females are better. You cannot make it. What is your hair color? It is a categorical variable, because whatever the labels are there, it's only value. You cannot arrange in some order. Where do you live? It is a kind of categorical variable. But if I say, how do you feel today? Very happy, unhappy, okay, happy, very happy. These are the ordinal variable, because among the label you have some meaningful ordering. Satisfied, not satisfied, like that. So these are the ordinal variable. All remaining are the continuous variable. If you talk about the numerical variable, real valued variable means typical numerical variable. Talking about maybe float variable, maybe numerical variable, whatever the variable you can consider as a numerical variable and continuous variable. Numerical variable, continuous variable again have some two more category. They are interval or they are ratio. Just I'm just flashing the name. I'm not going to discuss what is the interval and what is the ratio. So, but you should know the word ratio or interval is a kind of numerical variable. Just you can understand. Okay, just I'm skipping that part. Okay, let me show with the example. Let me show with the example. So, how do you know in the real life when you use the import the data, which variable is the categorical variable, which variable is not the category variable? How do you identify? How do you check it? So that thing I'm just demonstrate you. Then I will going to stop the today's session here. This middle one. So this is the way I'm going to import the data. Just you see I'm going to import the data that is already where I have written a string as a factor, a new parameter I have passed over there in the false. So what is the magic of that? You can understand. Just I enter it. str is a command that will give you idea about the data type, whatever the data type of each variable in the data set have. So just I have command str. You see over here that the data set I have uploaded, their age, gender, BMI, children, smoker, region, expenses are the variable. I don't know the category of that variable. I don't know the variable type, suppose. Okay, somebody have written the temperature. What kind of variable? That I request you to please have a look about the level, internal and the ratio. The the temperature is the internal variable. It is not the ratio. So somebody have asked. That's why I'm writing. So if you want to understand temperature is a what kind of variable? Temperature is interval. It is a numerical variable. Under the numerical variable, it is an internal variable. If you will say the weight of particular person in kg, it become a ratio. So I'm not going to that much of discussion because many important part I have to skip it. Okay. So that the data set I have uploaded into the R environment, I want to see which kind of variable these are. So how to upload the data is become very important over here. It is not very simple. You just write the command. You will see over here now. Age is an integer. Gender is the character. BMI is the numerical. So integer and numerical are same. Both are the continuous variable. Where integer means typical integer, where the floating while number comes into the data set are represent as a numerical variable. So you can consider numerical integer as a simple numerical variable. Children again a numerical variable or integer variable you can say. Smoker is the character and region is the character. So where is the categorical variable? So what I have done when I have uploaded the data, I say don't use your mind, your brain when you upload the data. That's why string as a factor I have set as a false. Means our environment just uploaded your data. It doesn't see anything other than whether the value is numerical or not numerical. So whether it is a female, a male, or a yes or no, or south or west, it is considering as a string or character, you can say. So our environment didn't put any brain while uploaded the data. But if I change the one line, I say it is true. I will say it is true. Now I am saying to R, please inspect each and every column. Please inspect each and every column and see the property and decide whether it is a categorical variable or whether it is a string or whether it is a numerical variable. Try to do that one. The moment I will do it, you will see data again uploaded and see now things have changed. Earlier, the gender was a character. Character means it is female, female, not other than that. Male means male. It is considering as a character. But the moment I categorize the data, it become a factor. Factor means categorical variable. The terminology is the factor. Factor having a two levels, male and female. means it make the category now. Earlier it was not a category. Earlier it was not a category. There is a male and female, but we were considering as a male or female as a only character, not only string. But now I'm saying to any algorithm, when you will use such kind of data, it is not a character string, it is a category. The machine does not intelligent like you. Machine have to understand it is a category or it is a character. So once you make feel or give the instruction to the algorithms, please consider gender as a category of a two label, male or female. Then it will say it is a class or it is a two category. Similarly, if smoker have a two category, yes or no. Because if I say I'm the smoker, yes, then you create some image. You can understand what is the meaning of yes. Yes means not in only ASCII value. But if you consider yes or no as a string, it will not put a more focus on whether it is a category or not. It will consider as a yes having some ASCII value. It will not take it as a category. So that is a big difference between them. When you convert the string or character as a category, a different kind of learning you will face. You can try by yourself with your student. You train your data with this one. With a simple way, you upload your data with the with the character or numerical without any intelligence, without making string as a factor false. You will see the very poor performance. The moment you will change your data, because the focus of the AI, this FDP is the pre-processing. So that's why I'm giving a lot of focus on training, test split or validation data split. And when you upload the data, it is not only to write the syntax. You have to be careful. So the moment you will upload the data in a different way, you will see the performance of the same algorithm. It will hike a lot. It will give you a good performance now, because algorithm now can understand if there is a smoker means the person have to go for more health issues in the future. Like that, algorithm can think. Okay, so that's why it is say the expenses with reflect to the related to the health insurance. So if the person is a smoker, yes, then you can understand smoker means it may have some lung on some health issues. So he has to spend a lot of money in the future. No means it is less chance to having such kind of complications. But machine don't know what is the meaning of yes or no. Then you have to say machine yes means machine this is the category, and no machine is a category. Don't consider is only string. That is the advantage of making the variable as a factor or categorical variable. It is okay with everybody? The chat box you can mention is okay with everybody? Okay. Oh, okay. So I think 11:55 is over, and now we have to 10-minute gap. We are going to start our next session after 10 minutes. 12 at 12 and 5 we are going to start our session. So